So this is our second part of our kinetic energy and potential energy notes. This section focuses on how to calculate potential energy. Remember that potential energy, there's two types. Gravitational potential energy, and that's the energy stored in an object because of its height or its position. So this car has potential energy because it's at the top of a hill. And there's elastic potential energy, that the energy is stored in the object because it's stretched or compressed. Think about a spring. When you push down on it, it's compressed. When you stretch it out, it's stretched. And that string is going to pop back into its original position as soon as you let go. That is a form of potential energy. When we're doing potential energy calculations, we are going to focus on the gravitational potential energy. That's what we are going to do the math for in this unit. The potential energy equation. The potential energy equation is potential energy equals mass times gravity times height. In symbols, it looks like this. PE equals mgh, where potential energy is PE measured in joules, mass is M measured in kilograms, G stands for gravitation due to gravity, acceleration due to gravity. It is always 9.8 meters per second squared. You can just remember that G equals 9.8 meters per second squared. Our last variable is height, or h, and remember that height is measured in meters. What I have for you here is what's called a triangle. You might have used a triangle in velocity equals distance over time. This is just a slightly more complicated triangle. If you're someone who's not too hot with algebra and you hate calculating, this might help you out a little bit. How you use it is you cover up the variable you're trying to solve for. So if I cover up potential energy, I'm going to find out that because they're right in a line, PE equals mgh. I'm going to write it off just as I see it, mg and h. If I tried to solve for a different thing, if I tried to solve for mass, I cover up mass, and I'm going to find out that mass equals potential energy divided by g times h. Right here I draw that line because I see a line. Potential energy divided by g times h. If I then decide to solve for height, I'm going to cover up my height, and I'm determining that h equals my potential energy, which is on top, divided by mg. This triangle you will see on a test to help you out here in knowing these different equations, just like you will see these different equations on the test. Remember that in solving problems, we're going to use these 6 steps that were discussed in the other video. Steps for solving problems. 1, identify what the question is asking. 2, identify the variables. 3, write the equation. 4, insert the known variables into the equation. 5, solve. And 6, double check your units. Remember that these first 4 steps are going to be your really important ones, and the solve is going to be your least important, but you will have that calculator on the test. Let's practice solving some of these problems now. First one, if 50 kilogram object is located 4 meters above the ground level, find its potential energy. Step 1 always says to identify what the question is asking. I see this word find here, so I'm going to look around that word find, and it says find potential energy. So I must be trying to solve for potential energy. Now I need to identify the variables that I know. First, I'm going to start with mass. Mass has a unit of kilograms. I'm going to find that kg in my equation, or my problem, and I'm going to see a 50 right before it, so I know my mass must be 50 kilograms. I'm going to continue on, and the next part is g, which is always the same, 9.8 meters per second squared. Finally, the last thing that I have to identify is my h. And h has a unit of m, or meters, so I'm going to look for that m, and I'm going to see that there's a 4 right before it, so I must know that my height is 4 meters. Next, I'm going to write my equation out. PE equals m g and h. Next, I am going to replace my variables with the numbers I determined them to be. So I'm trying to find PE. I don't know it yet. PE equals, my mass is 50. G is always 9.8. And my height is 4. So I'm going to very simply type these three numbers into my calculator. 50 times 9.8 times 4. And I'm going to find out that my potential energy of this object is 2,450. But I am not done. I need to add units. Remember that potential energy has a capital J for joules. Let's do another one. A 12 kilogram cat who is resting on a tree has a potential energy of 50. Calculate its position or height relative to the ground. So step 1 says identify what I'm trying to solve for. I see the word calculate. The other thing I see in that sentence is height. So I must be trying to find the height. Next, I need to identify the variables I know. Potential energy has the unit of a capital J. I see that right here, 50 joules. G is always going to be the same, which is 9.8 meters per second squared. And my mass, our units of mass, is kg. And I look for the kg up. There it is. I have a 12 before it, so my mass must be 12 kilograms. Now is one of those situations where I'm solving for something other than PE. So I'm going to use that fancy little triangle. And I know that it's P on top, then it's M, G, and an H. So I am going to cover up that H and see that H equals my potential energy divided by M and G. Now it's time to plug in the numbers that I do know. I'm still trying to find H right now. My potential energy, though, we said was 50 joules. My mass was 12 kilograms. And the acceleration due to gravity is, like always, 9.8. So I'm going to type these numbers into my calculator, and I'm going to get that my height is 0.425 meters. All right, one last problem here. A girl rode up a 5-meter high flight of stairs, and she had 1,000 joules of potential energy at the top. Calculate the mass. So I am trying to find here mass. Step 1, done. Next, I need to identify what I know. I know that potential energy has a unit of J, so I know that my PE equals 1,000 joules. G is always going to be the same at 9.8 meters per second squared. And my last one is height. Height has a unit of m, so I know that my height is 5 meters. Again, I have a situation for that triangle. B divided by m, g, and h. I divide it up. I cover up the m. I see that it is potential energy divided by g and h. So PE divided by G and H. And putting numbers here is going to find me my mass. So time to actually type in numbers for the letters. My mass I don't know yet, so I'm going to leave as a letter. My potential energy has 1,000 joules. Acceleration due to gravity is always going to be 9.8. And my height is 5 meters. I enter all of these things into my calculator, and I find out that my mass for this little girl is 20.4. Am I done? No, I need to make sure to include units. This is in kilograms. So this concludes our potential energy segment of our notes for today. Please do not panic if you're having trouble with these. We're going to do many more practice problems. Please do not hesitate to